Hello, grade 12. Mr. Stolle here from your tutors. So today we have a paper here, a question 4 from Eastern Cape, June 2023. Okay, but before I continue, you can see here the hashtag is time yourself. What do I mean by that? Make sure that you use the time that you are given, the allocated time here, to use it to measure how fast you can actually beat the time. Because now if you check there, to check how much time you need per minute, you can say 180 minutes divided by 150 marks. This is going to give you 1,2. And if you say 1,2 times, in this case, 19 marks times 19, what you'll get there is going to get 22,8, which is actually 22 minutes. Now, so for you to beat this time, you must practice now. So whenever you're attempting a question, try to time yourself. Okay, let's look at this question here. It's a parabola and a parabola. And what we have, the question is saying the diagram below shows the graph of f of x, which is 5 over x plus p plus q, and g of x, 5x squared plus 10x plus 3. The two graphs intersect at S. Okay, they intersect at S here, that's the point of intersection, which is the y-intercept. So always remember y-intercept, x is equals to 0. Okay. Then R is a point, R is the x-intercept of f. So here at x-intercept, where the graph cuts the x in the axis, y is equal to 0. Now, the asymptotes of f cut at T, the turning point of G. So here we have got the turning point here, and turning point is turning point of G. But what we also see that these two values here, the P, your P is actually your horizontal shift. So it's left and left and right shift. Then your Q is up and down shift. So it's actually vertical shift. That's what you must always remember. So what it means here, it means that this graph was shifted by Q units down. So this here is y is equals to Q. Then here I want to tell you something here is different here. When you're looking at this, you can't just say x goes to p, but put it as negative p. What do I mean by that? Whatever value of x that you find, of p that you find here, you must actually make it use the opposite sign. Because when you move, when x is positive here, you shift to the left. And when x and p is negative, you shift to the right in order for you to not have, the 0 at the bottom there. Now, the first question here is saying, write down the coordinates of S. Now, when they say write down, there is no need for calculations there. No calculations needed. And you can also see that 2 marks. But now, where do we get the S? S here is y-intercept, and y-intercept x is equal to 0. So we're going to use the g of x here to get our S. So our S here is going to be, it's a coordinate. So remember to put both x and y. Okay. So in this case here, we know that it's a y-intercept, so our x is going to be 0, but our y is going to be 3. Because if we put 0 there and we put 0 there, we're going to be left with 3 only. Okay. Now, the second question is saying, determine the coordinates of T. Now, T is a turning point. T is a turning point, and what we know about this is that this g of x is in the form of, ax squared plus bx plus c. And what we know from that, we know that to find x coordinate of the turning point, we say x is equal to minus b over 2a. Okay, now minus b over 2a, what we have here that a is equals to 5 because the coefficient of x squared, and b is equals to 10 because the coefficient of x. Now we're going to substitute here, and we're going to have minus b is 10 over 2 times 5. Then you get negative 10 over 10, which is going to give you negative 1. Okay. Then for us to get the y, we are going to substitute x in the equation. So we're going to say, okay, here g of negative 1 is going to be equals to 5, negative 1 squared plus, what is it? What we have there? Our b is 10. So it's 10 negative 1 plus 3. Then if we are to punch in the calculator there, we are going to have 5 negative 1 squared plus 10 negative 1. Then we are having plus 3. Then what we get there is negative 2. So our answer there is negative 2. So our coordinates of t therefore is equals to negative 1 and negative 2. Okay, so here the next question here is asking us to find the values of P and Q. You can see that is 2 marks here. This is 4 marks there. 2 marks there. How are you going to get those 2 marks? You know that P, you are given already. P is your, what is it? It's your 1. So P is going to be 1. Remember what we said, it's opposite of that. So P is equals to 1. Okay, and Q, you take it as it is. So Q, you take it as it is here. It's going to be equals to negative 2. So it means that the graph has been moved 1 into the left and what you call 2 units down. Then length of OR. Length of OR, we're just looking for the x coordinate. So the coordinate of R, that's what you're looking for, which is the x index, the x value. So how do we get that? How do we get that? We only get the x-intercept when y is equal to 0. So if we are to write the equation of f of x, so f of x here, let's use another color there, is equals to 5 over x plus 1 minus 2. Then if we are to equate this to 0, we're going to have something like 5 over x plus 1 is equals to 2. Okay, then we take that one to the other side. 5 is equals to 2x, so it's going to be 2 times x, then plus 2, which we have 2x is equals to 3x is going to be equals to 3 over 2. Now 3 over 2 is actually 1 over 5 units. Okay, so here our OR is 1 over 1,5 units. Okay, that's what it means here. That's our answer. Then range of G, range, remember, range, we're looking at the Y values only. So Y values approached by the graph is going to be from negative into up until infinity. So here our answer there should be Y greater than what you call or equal to negative 2. Okay, so that's our range. So the range here, graph starts, its minimum value there is negative 2, and it will go up until infinity. Now let's move on to the next question. Determine the equation of the tangent to G at S. So let's just use this. Let's use a fresh slide. Now here, tangent to G at S. Now when you're looking at the equation is going to be in the form of y is equals to mx plus c, because the tangent is a straight line, and what we are told here is that the tangent is actually passing from there. Let me just get my ruler there. Okay, so here it's gonna be like this. That's our tangent there. This is the tangent that we're talking about. It's passing at S, and what we can now see is that if it's a tangent to G, sorry. So a tangent to G, so it's gonna be like this. It's gonna be the opposite. Okay. Okay. Okay, so that's our tangent there. So it's gonna be like that because it's tangent to G. Okay, so here let's just get rid of this line here. Okay, now so that's the tangent to G, and the tangent to G is passing at a point, and at that point we already have it, because for us to get the equation of a straight line, what we need for equation of a straight line, we need a point and gradient. So for you to get equation of a straight line, you need a point and a gradient, and for you to get the point, we already have it, which is 0 and 3. What about the gradient? Gradient, we know that you're going to use differentiation. We're going to use a differentiation here. So we're going to say G of the first derivative of x of G is going to give us 10x plus plus 10. Okay, now what we know here is that when we are looking at this, we're going to say, okay, the tangent is going to be equal to, and x value there is 0. So g of 10, 0 there is plus 10. So what we will get there is going to have 10. Okay, so the gradient there is going to be 10. So once we have the gradient is our m. So this is our m. And here our c is y-intercept. So this is our y-intercept, which is 3. So the equation there should be equals to y is equals to 10x plus 3. So we are done like that. So that's what you need to do here. So remember, whenever you're looking for an equation, don't forget that differentiation, you apply it in whichever topic. So don't limit yourself and say, I'm doing functions. Why should I apply calculus here? You should apply calculus because know that first derivative is equal to your gradient. So here, another thing that you must master, the first gradient. So m is equals to f the x or gx, which is our first derivative. Okay, that's what you must know. Now, let's look at the next question here. Determine the equation of x of symmetry of f with a positive gradient. Now, so I'm going to use a fresh page again. Here, when you're talking of with a positive gradient, you've got two x of symmetry. So you've got one, which is a positive one, and the other one with the negative one. So I'm just going to give you both of them, okay? I'm just going to give you both of them. Let me just show you here. Okay, so here is our positive gradient. So here, the one with the positive m, and this one is the one with what you call negative gradient. But in general, we must understand how do we put that? How do we put it when you're given in when the equation is in this form? What you need to know that the equation, the negative with the negative gradient, you get it by saying y is equals to negative in bracket x plus p plus q. So whatever you have here, you just take it as it is, you put it in the bracket, then you put negative outside to get the one with the negative gradient. Then the one with the positive gradient, that's what we are looking for now. You're going to get it by saying y is equals to x. So here, x plus p plus q. So you don't put anything here. So it's just x plus p plus q. That's it. That's your equation for the positive one. So the reason why I'm putting the bracket here, just show you that we're not putting anything outside, but here we need to put a negative outside. So just for next time, you must remember that whenever they say positive, you know what to do. When they say negative, you know what to do. Now let's actually answer the question here. So the equation is now f of x. Let me use f of x. F of x is equals to 5 over x plus 1 minus 2. So in this case here, our equation there should be therefore equal to y is equals to positive gradient. It's going to be, we're just going to take the values as they are. So it's going to be x plus 1 minus 2, which is going to be equals to x minus 1. So here our answer is going to be y is equals to y is equals to x minus 1. Okay, I didn't draw it nicely here. Maybe what I need to do here is just to tilt a bit, to tilt it. Okay, to tilt it a bit so that it can match what they are talking about here, that is passing at -1. Okay, we are not asked to draw here. I'm just doing it so that you can see what we mean by what we call this type of graph. So here it means that the y-intercept here is going to cut at -1. So -1, we are assuming that is actually what is it? It's actually there. Then here is -2. So that's what it means. So now we are done. That's the equation for the positive gradient. And if they were to ask you the negative gradient, let's just do it here. It's going to be y is equals to negative in bracket x plus 1 minus 2, which is going to be equals to negative x negative 3. Okay, so this will be equation with the negative gradient. Now let's go on to the last question here, which is saying for which values of x will g of x, the derivative of x, this one here, when you're talking of this one, remember it's gradient. It's gradient. First derivative is gradient times f of x is less than 0, less than or equal to 0. Now, let me just show you something here. So if we are, for us to get, when you are told that it's less than 0, it means that what we need to get here is a negative. Okay, the answer should be negative. So what must we do? Let's me write it again here. It's going to be derivative of g of x times f of x is giving us some less than 0. So it's here, we need an answer which is negative. So how can we get a negative? It's either we have a negative derivative, then times a positive, then that will give us a negative. So we look for where your graph, where we are saying g of x, in this case, g of x is negative. Remember, here is decreasing. So here is decreasing and there is increasing. So here, m for this one here is negative up until this part here is decreasing. Then m here is positive from the turning point up until infinity. So we have the turning point again. So m here is negative, x less than what was this one here? What did we find as our x? It was 1. So x negative 1. Okay, and x is positive here. X is gradient is positive for x greater than a negative 1. So it means that our graph is increasing from turning point here up until infinity, and it's also decreasing from turning point up until negative infinity. Why am I telling all this? Because some questions will come and ask you that determine the value of x, where your graph is decreasing or where your graph is increasing. You must understand that decreasing, negative gradient, increasing is a positive gradient. Now let's come back now to another question. So here we are saying where is negative is going to be negative here. And is our f of x positive? We don't have anything like that, because here what we see is that where this one is negative, we are seeing that g of the f of x is negative as well. Okay, so now when you're talking of negative here, it needs to be above above the y-axis. Now let's move on to the next question. So next category. So here we take it out, we don't have it. Then next category here that we can have is that we can have this as a positive and our g of x as negative. So here it's gonna be negative. Our f of x is negative. So here we're saying is negative, so that we can get a negative value. Now, where do we have that? So if we are to check here, our gradient is negative, it's positive from this point here up until infinity. But where do we find our g of our f of x negative? So we are saying here our f of x start to be negative from this point here. But we already know that our derivative of g, which is the gradient, is positive until infinity. But this one here is going to be negative from the value here. We got it 1,5, which is 3/2. Is going to be positive from the negative from this point here up until also infinity. So that's what we see. So here f of x is actually negative. That's what we see. But g of x, the derivative of g, is positive. So we are saying from this point here up until infinity that's what defines your answer. So here the answer should be x greater than or equal to 1/1,5 or 3/2. Okay. Okay, this is it, guys, for today. Okay, all the best in your exams, and don't forget to subscribe on our YouTube channel and also follow us on Facebook. Guys, remember, if you have any question, feel free to contact me on those numbers. Okay, thank you so much. All the best in your exams.